Welcome everyone to today's live stream. Something more from work, because usually certainly doing a little bit more for hobby kind of thing here, but certainly don't really can and want to live stream other work related stuff. But today one of those chances, except when we soon continue with our microkernel and stuff, but sort of kinda live from work. I mentioned this in another vlog. I was ISO project leader for PDF raster, a strict subset of PDF for pure pixel image raster transfers for indirect cloud scanning and stuff, but also here previous videos and web and stuff. But today I want to take a look in this work. And by the way, amazing standard, right? Like 17 pages or so, of which title and footer and all, and so like 15 pages standard of keep it stupid, minimal, simple. So today some state-of-the-art research for the PDF working group, or ISO PDF working group 8 something WG8 of that sort. And yeah, who is doing this kind of state-of-the-art research? Certainly small and individual unsuccessful women companies, not like us. And so what is it about? So currently PDF, the highest image compression you can put into PDF is JPEG 2000, and as a name implies, JPEG 2000 is already 20 years old as nearly as old as our Linux distribution or our SGI Octane previous video. So JPEG 2000 is entirely different from JPEG. So JPEG is working on 8x8 macro blocks with some relatively old-fashioned compression, and JPEG 2000 is using wavelet compression. I guess so JPEG 2000 significantly better. Here's some CDF503 wavelet using lossless compression of, yeah, with this amazing wavelet stuff you can actually compress images. But even this is, as I said, 20 years old. And yeah, we actually use that. It is significantly better, but also significantly slower and so on. But again, this is 20 years old, and wouldn't it be nice if PDF, the portable document format that you all love and use every day, would support something new, such as high efficiency image file format. So this is, what is that? That is a general term for everything new and high efficient, as the obviously name applies, right? So what this is using state-of-the-art and highly efficient compression of motion picture stuff, of videos like this channel of Google and Netflix and what all you consume and so on. And so what this means is X265, and certainly because we don't want to use this highly patent encumbered stuff, or that is X26 or H26, 4 and 5. This is also what many people don't realize. If you make a photo on your favorite iDevice of the last years, you actually don't get JPEGs anymore, right? So Apple is already using this, and some Android phones are using this also. So what they are using is the keyframe compression of this highly efficient codecs of H265 and similar codecs like AV1. Here of Google's and others alliance of open media file format, and don't use the other motion picture stuff, but because it is delta compression of how those new formats work, video codecs work, is as you probably guessed, is finding predicting changes and using previous segments of parts of the image, blocks of the image that were already previously seen the last second or so, and like copy them, like instead of creating some first of all data encoding of various kinds. And certainly this is also what they've done already in the 90s, but of course over the last 20 years more tricks, more data encoding, more prediction and so on. So that is basically the summary. So what we want to try to do is push this also, because today you can create photos on iOS and Android that you can't directly place in a PDF without a significant increase of image size. And for cloud scanning and cloud image exchange and the future, obviously it would be nice to have this also. Why I work on this is, if I, like independent, successful people here, if we let Adobe and Microsoft do this, we might more likely end up with stuff using highly patent encumbered stuff like H2 something. Here somewhere was a patent list, patent licensing. So also somewhere was I in patent holders, was I not? Here probably I was. So active patents, if you were, wait a second, is this, don't tell me this is, yeah, high efficient video coding. And so the issue is with that, and why I even look into this, I want to push the industry to adopt an open standard, because if we let Adobe, Microsoft and Apple and stuff do this, then we end up with PDF 2. Whatever, 2.1 or whatever the next standard might be, adopting H265, and certainly nobody of you and me wants this. And also, fun fact, so if the ISO PDF stuff is ending up using this highly patent, and I personally want them. It's like when we are in a meeting, this stuff, in a meeting with this companies, it's like, yeah, we and many others in the industry don't really see supporting a highly patent encumbered codec, and Adobe and Microsoft is like, yeah, whatever, but it's amazing. And so yeah, this is why you and me and all the small companies, it's much more important that feedback from like highly skilled, trained and so on professionals provide feedback and work on the standards. For otherwise standards are yeah, there were 14 not as amazing standards, and now there are 15. So yeah, what I do today, and probably we continue on the main channel, this is just the summary, and otherwise if I do here everything live on this channel, then people don't like it as much. Here, by the way, coding trees, and so here a lot of high-level details of intra. So how video in general works, maybe one last sentence, and we move on to the more live channel and do some open Linux work, which is also amazing, that as much as overworked and like, hey, contributing to ISO standards where actually all the big companies sit and stuff, but there's more people doing also, hey, can you implement this proof of concept? Yeah, sure, EXA can do this, but other companies are waiting for some proof of concept implementation. But so if you don't know how video codecs work, this might be interesting. Is even in the 90s, the first video codecs, MPEG and Intel Indy or whatever that was. So usually you have a keyframe, so you encode a keyframe, which a keyframe is where all the informations are in, like a photo, basically some sync JPEG, and back in the day there was even MJPEG or some motion JPEG. So you have a keyframe that is a whole frame, like a photographed image, and then you have iframes, the interframe of intra-picture encoding and estimation, so that you have like one keyframe and for every 15 or so intra-frames. And you see a high-level block diagram of HEVC, so that we have here the input video signal split into the CTUs and general code control stuff, controlling what to do on each frame, transform, scaling, quantization, intra-picture estimation. So what this is doing is estimating how the stuff is moving. If you have a car and it's like, certainly it's not jumping zigzag like an UFO. So if a car or a person, certainly they walk there and drive there at some certain linear behavior, so that you can estimate how the pixels will change and spread and move in the picture. And what happened, or what is the difference between the codecs of the 90s and the 2000s, is that this intra-picture estimation and prediction and motion compensation and all the surrounding transforms much similar to setlib and bzip2 and now set standard, just much more advanced coding also, and much more fine-tuned and state-of-the-art encoding of reusing parts of keyframe images in this intra frames. So what I will do the next days as part of my voluntary free time of not only running a Linux distribution, but sure, we can also implement some proof of concept next generation PDF encoding. First, we will package some packages in T2, so this is the usual super boring task. And then I will extend our PDF library, because fun fact, we have one of the most amazing PDF libraries, because certainly you don't want to run all this stuff from the other AAA companies. And with all the C implementation of security vulnerabilities, because certainly ours is not implemented in C. And so yeah, first packaging some stuff for T2 Linux so that you can run it on PS3 and SG Octane and stuff. Packaging here the AV1. So what I will propose is AV1, which certainly not messing with H265, because I don't have money for all the patents. And so Alliance AV1, Alliance for Open Media. What is here? OS 10. What is it? Codec royalties. What does it have? Codec royalties? Why? Since when does? 0. What did I somehow misread this as 10? So the others have, of course, here, yeah, like codec royalties is like, yeah, you had me at codec royalties. So yeah, I will try to propose this AV1, which also exists. If you want to use this today, you can already do so with GIMP, for example. So there is AV1 something of AV HEIF, and this is what we know on the mod channel. This is only a brief summary of that. You maybe heard some new stuff of video codecs and what is happening in the industry. So open source, so we'll package here some stuff, and then I will proof of concept integrate this in our PDF library, maybe at some later date, but I might write such a codec from scratch in Rust or our own just-in-time compiled language. But we will see if the ISO working group does not adopt this. It makes no sense to write a codec. So for the proof of concept, I will use whatever open source codec are there. There's some C reference codec, some Rust codec. So let's move over to the more random channel. Let's spend some 30 minutes or 40 or something here of kind of sort of lunch break time or so to package this, to see if it works. And then I will use some of our test suite samples of certainly we are professionals and work with test suite stuff in our image processing and PDF library and products and stuff, not like other people there of ASUS and stuff, of just doing something and hoping and letting customers test this. Anyway, if you want to join this Linux work, more random channel there, and let me think, probably that corner there, also of recommended channels. Otherwise, I hope you learned something from this rough brief summary. I'm still experimenting with this YouTube channel, how to best grow this and present some information. I hope you learned something, and to see you soon with all the more live and next videos to come.